You ever have one of those moments? You're staring at this gorgeous fruit tree in your yard. It's got lush green leaves, strong branches, it gets plenty of sun and water, and you're just thinking, why on earth won't you give me any fruit? It's one of the biggest mysteries in gardening. Well, today, we're going to solve it, because it turns out your tree is running on a hidden schedule, a secret internal clock.
So really, why won't it bloom? I mean, you've checked all the boxes, right? The water, the fertilizer, the sunlight. You feel like you've done everything right. But here's the thing. The problem isn't what you're doing now. It's about what happened, or maybe what didn't happen, last winter. The answer lies in something way more ancient and precise than your watering can. And yeah, the culprit is this hidden biological clock. Deep inside the tree, there's a silent countdown that's been running all winter. Or, in some cases, a countdown that's failed to run. Understanding this clock, that's the key to everything. So, let's dive into what feels like a real biological detective story.
Okay, first up, we're looking at the core problem. We'll call it the case of no blooms. It's this super common yet really puzzling issue of a perfectly healthy-looking tree that just refuses to flower. And the reason why is surprisingly sophisticated. Now, to solve this case, we have to get one thing straight. The tree isn't being stubborn. It's being incredibly cautious. It's operating on a survival code that's been perfected over thousands and thousands of years of evolution. And this code is designed to protect it from one very specific and very lethal threat.
And what is that threat? It's the false spring. Just imagine it. It's a beautiful, warm week in the middle of January. If the tree gets tricked and bursts into bloom, what happens a week later when a totally predictable freeze comes through? It would kill all those delicate flowers. It would completely wipe out its chance to reproduce for the entire year. So to avoid that catastrophe, trees evolved a kind of internal lock that can only be opened by a long, sustained winter.
So that brings us to the mechanism itself, this hidden winter countdown. See, the tree isn't just passively waiting for winter to be over. No, it is actively measuring it, hour by hour, using a system we call chill hours. And what's so fascinating here is the precision of it all. A chill hour isn't just any cold hour. It's an hour the tree spends in a very specific temperature sweet spot. We're talking roughly between freezing, so 32 degrees, and about 45 degrees Fahrenheit. This is the productive cold, the stuff the tree is actually counting. But the rules get even more specific, and this is where it gets really interesting. If the temperature drops below freezing, the tree's metabolism is basically too slow to even register the time, so that hour doesn't count. And get this, if it gets too warm, say above 60 degrees, some of the science shows that the tree can actually lose or subtract the chill hours it's already banked. It's a really complex calculation.
So what is actually happening inside the tree's buds while this countdown is going on? I mean, on a molecular level, it's this absolutely incredible process. Let's go inside the clock itself.
You can think of a tree's winter sleep as having two phases. The first is called endodormancy. This is like a deep, deep sleep. It's a biochemical lock. You could literally take that tree and put it in a warm greenhouse, and it still wouldn't grow. The only thing that can break this lock is accumulating enough of those chill hours. After that's done, it enters ecodormancy. Now the lock is off. The tree is ready to grow. It's just waiting for the final signal, sustained warmth.
And all of this is managed by a kind of hormonal tug-of-war. Think of this one hormone, abscisic acid, or ABA, as the sleep molecule. Its whole job is to keep the buds dormant. But as those chill hours add up, the ABA slowly breaks down. Once it's pretty much gone, the wake-up molecule, called gibberellins, or GA, can take over. And that's what triggers the explosive growth we see as blossoms in the spring.
And this brings us to some of the latest science, which is just mind-blowing. The whole process is epigenetic. This means that the cold exposure literally causes physical changes to how the tree's DNA is packaged, silencing the genes that prevent flowering. The tree doesn't just count winter, it physically remembers it in its cells.
So, what we have here is this elegant, ancient system. It's amazing. But what happens when it breaks? Because in our modern world, this finely tuned clock is facing a major threat that's throwing its timing completely off.
As our winters get warmer, we're starting to see a critical winter gap. For example, a peach variety that needs 800 chill hours to wake up properly might only get 600 in a modern Georgia winter. That means it's left waiting for 200 hours of cold that just never arrive.
And the consequences of that are just devastating. Leaves come out late and all patchy.
The few blossoms that do manage to appear are weak and they just fall off. And any fruit that actually manages to set is often small or misshapen. The entire rhythm of the tree is broken.
Now, this all sounds pretty grim, but it's not hopeless. Now that we understand the mechanism, we can actually develop strategies to adapt. This is where the science of horticulture really has to meet the reality of our changing climate. So for home gardeners, the single most important step is choosing the right tree from the start, a low-chill variety that's been bred for warmer winters. Commercial growers, well, they can sometimes use chemical sprays to sort of jolt a tree awake. And you can even play with microclimates in your own yard, like planting on a cooler north-facing slope to try and maximize whatever cold you get.
And as our climate changes, our understanding gets deeper too. Scientists have developed more and more sophisticated models to track these chill hours. We've gone from the really simple Weinberger model to the dynamic model, which understands that chill can be locked in and can't just be reversed by a warm spell. Our science is adapting right alongside the trees.
Ultimately, this quote just captures it perfectly. The tree is a historian. Its decision to bloom isn't some random guess about what the future holds. It's a confident judgment based on the recorded history of the winter just survived.
So the next time you look at your fruit tree, don't just see branches and leaves. See a sophisticated biological timekeeper. And ask yourself this: in our warming world, is my garden's clock still set for the right time zone?